Welcome everyone to the General Chemistry mini lecture series. I'm your instructor, Professor Frank. This mini lecture series is designed to provide you the opportunity to efficiently learn one chemistry subject matter at a time, actually a pretty short period of time, mostly less than 10 to 15 minutes. Another beauty of using this mini lecture series is you can learn chemistry very comfortably whenever you feel like and wherever you feel like. This mini lecture series also contains end of lecture quizzes, something like this. This is for actually the first lecture. And those quizzes, you can use them to review the lecture material, to digest and comprehend the subject matter, and then prepare for in-class tests and quizzes. Obviously, you have to work on much more homework and practice problems on the subject matter. And to help you with that, I also produced hundreds of video clips on solving and explaining homework practice exam problems. You can take advantage of those video clips. So therefore, it's a good idea that you subscribe this YouTube channel so that you can have it with you anytime when you need it. Happy learning! Now, let's start Lecture 1. Matter, atoms, molecules, and compounds. First, you may ask me, Professor Frank, why should I study chemistry? I can tell you, chemistry is the central science, and that is the reason. Chemistry is very important to other fields of science, for example, biology, medicine, engineering, astronomy, physics, and many other areas of study. Chemistry plays an important role there. So that's why you need to study chemistry. Then you may still say, I don't care about chemistry, so why should I study? My answer is, you'd better do. You should care about chemistry. Why? Because there are 37,000 billion chemical reactions per second occurring inside your body. That's why you'd better care about chemistry. For example, respiration is the chemical process by which organic compounds release energy. Whatever you do, you need energy. And during the process of respiration, for example, glucose breaks down into carbon dioxide and water. During that reaction, 2,870 kilojoules of energy is released. And here's the chemistry language describing what exactly what just talked about. One of the 37,000 billion chemical reactions occurring inside our body. So that's the chemical reaction. And this means this reaction releases this much energy. That's why you should care about chemistry. Furthermore, chemistry is everywhere in our world. All the everyday objects that we can touch or squeeze, they are all composed of atoms. And atoms are very tiny. Then you may say, wait a second, everything is made of molecules. Yes, but molecules are made of atoms. So therefore, almost everything is made of molecules or compounds, but molecules or compounds are made of atoms. So atoms are the smallest units of matters, the building block for matters. Let's take an example. Water contains H2O molecules, water molecules. And each water molecule consists of 2 hydrogen atoms and 1 oxygen atom. Molecule is not the smallest unit of matter. Atoms are. As of 2016, there are 118 confirmed elements, but more than 9 billion organic compounds. Just 118 types of atoms can form 9 billion organic compounds. That's the difference between molecules and atoms. That's the 118th. Start from first one, hydrogen here, all the way 118. Everything in this universe is made of those 118 elements. Although we say atoms are the smallest building block for matter, they are not the smallest particles. There are subatomic particles such as protons, neutrons, and electrons. If we take a look at atomic structure, the entire atom is almost like an empty space. It's right in the center, there's a so-called nucleus that contains both protons and neutrons. And then there are electrons surrounding the nucleus. Electrons are found in this vast empty space. So we call this actually electron cloud. That's the atomic structure. Let's take a look at the properties of the three key subatomic particles. We have protons, those are the simples. Actually, they carry positive 1 charge. And then we have neutrons, those are the simples. It is neutral, does not carry any charge. And then electrons, it carries negative 1 charge. And then if you look at the mass, you see protons, they are slightly lighter than neutrons. Okay, the unit here is an atomic mass unit. It's a very small unit. You see, each AMU is equivalent to 1.66 times 10 to negative 24 grams. Very small, very, very low mass. But look at the electron's mass. It's less than 1,000 of proton and neutrons. What does it mean? It means the nucleus is very, very heavy. Since protons and neutrons are much, much heavier, therefore the weight or the mass of an atom is concentrated in the nucleus. So that's the relative mass, and here is the absolute mass in grams. And again, here are the locations, so you can find protons, neutrons in nucleus in the center of an atom, and then of course electrons outside nucleus in the so-called empty space. Now let's talk about Dalton's atomic theory. All matters consist of atoms. Atoms of one element cannot be converted into atoms of another element chemically. Of course, there are other ways to convert, but chemically, atoms of one element cannot be converted into atoms of another element. Atoms of an element are identical in mass, and all properties are different from atoms of any other element. It means atoms of hydrogen, for example, they are all the same. And they are different than the atoms of, for example, oxygen. Compounds are composed of atoms. So compounds result from the chemical combination of a specific ratio of atoms of different elements. For example, you have H2O for water, CO2 for carbon dioxide, CO for carbon monoxide. You see, CO2 and CO, they look quite similar, but they have very, very different chemical properties. Well, CO2 is non-toxic, carbon monoxide, CO, is very toxic. Let's take care of the definition for matter first. Matter is the physical material of the universe. Matter is anything that occupies space and has mass. For example, air is a matter, even though we could not see it, but it occupies space and it has mass. Yes, air has mass. Atoms are submicroscopic particles of elements, very tiny ones, and they are the fundamental building blocks of ordinary matter. Molecules are two or more atoms of nonmetals attached together through covalent bonds. For example, you have two hydrogen atoms, so they form chemical bond, covalent bond, and then hydrogen molecules are formed. So does oxygen O2 molecule. We call those diatomic molecules because that's two atoms of the same element form molecules. Or we can also have atoms of different elements forming molecules. Like in water, we have two hydrogen atoms and one oxygen atom. So we have two different elements. Carbon dioxide, same thing. We have element oxygen, two atoms, and we have element carbon, one atom there. So they are all molecules. Of course, those are not diatomic molecules. Only those are the diatomic molecules. Okay, molecules come in different shapes and patterns. Or in other words, the covalent bonds actually formed in specific geometrical arrangement, or they have different molecular geometry. You see, while those diatomic molecules, they are linear, the shape is linear, and also this carbon dioxide, that's a linear molecule, or molecular geometry is linear, then water is not linear. It is bent. So we'll learn more about that in the future. Compounds are formed when atoms of at least two different elements combine. Okay, here we have two different elements, so therefore those are also compounds. You see, nonmetals can form molecules and compounds. So in this case, compounds and molecules can be used interchangeably in this case. But there's another type of compounds formed between metal and nonmetal, like in table salt, sodium chloride. Here you don't have single NaCl molecules, like CO2, water. You don't have those individual molecules anymore in the ionic compounds, or compounds formed between metal and nonmetal. Instead, you see you have those crystals. The mechanism here is the attraction between the cation and the anion, the two opposite charges. So that's a difference between compounds and molecules. Metal and nonmetal, they can only form compounds. So when they come together, they can never form molecules because you can't find single molecules, as I just mentioned. And I already pointed out compounds and molecules can be used interchangeably in most cases. Here shows the end of chapter quiz. You can use those materials to review the lecture notes and to comprehend and digest the lecture material, the subject matter, and prepare for tests and quizzes. And as I mentioned in the introduction slide, obviously you need to work on many more problems similar to this so that you can perform better on tests later on. Let's just quickly take a look at the first one. Which of the following is a molecule? What is a molecule? Molecules are two or more atoms come together through covalent bonds. Covalent bonds means they have to be nonmetals. Based on that, you have a metal here, A is out. You have potassium, that's a metal here, and you also have D out. And now remaining B and C. O, is that a molecule? No, there's only one atom here that is just an atom. So therefore B is a molecule. And that is actually a diatomic molecule. This is a mini lecture 1, and I will see you guys in lecture 2.